Okay, welcome back to Transformations. We're now going to be talking about vertical stretches and compressions and horizontal stretches and compressions and the effect that it has on doing these to our graphs. Okay, so the big word I want you to remember here is multiplying. Because before, when we were doing transformations by shifting it to the right and left or vertically, up and down, we were adding and subtracting. This, all the time with stretches and compressions, have to do with multiplying a function. So you're going to be multiplying a function by a constant and understanding the effect of multiplying the input variable of a function by a constant. So, for example, the constant, they use k for a constant, so let's show what this looks like here. So here's k is my constant. Sorry. So here's k is my constant. Now, a constant could be any number, but in this case I want you to see you're going to have whole numbers, like I'll say 4, but you're also going to involve fractions, and you'll see where you'll say 1 over k, or you'll see something like 1/4. So you're going to see that you're going to have fractions, as well as you can also use it as decimals when we talk about this, when you're multiplying it by. Okay, so let's look at this one graph, and of course I've come back to the graph of y equals x squared, and we're going to actually stretch this graph. So here again I have f of x equals x squared, or y equals x squared, and I wrote down some of the points that we've had before. And then here's y equals x squared right here, and then what I did was I stretched it, and if you look at what I did was in front of the x squared, so here's y equals x squared. So there's my y. I multiplied the y's by 3. So basically on my points, I'm taking all my y values and multiplying by 3. In doing that, so here's my new table that I have. In doing that, all my x's remain the same. I don't know why the 1 won't show, but there's a 1 there, guys. I don't know why it won't show. There it goes. And then what I'm going to do is take all my y's and multiply them by 3. So I have 27, 12, 3, 0, 3, 12, 27. And when you do that, if you'll see what happens to my graph is it looks like it's been stretched. It looks like someone took that silly putty that you used to get, and you can take it and stretch it and make the face look weird or long. So this has basically been stretched, if you will, vertically. Okay, and it looks like it's closer to the y-axis is because it's been stretched, so it looks skinnier, if you will. Okay, so it's been stretched vertically, and your y's have all gotten larger, so it's growing quicker, if you will. All right, now let's look at this graph, same one, y equals x squared, and now what I'm going to show you, what I'm doing on this one is, here's my y equals x squared, and you'll notice I'm multiplying it by a half. So I'm doing a half times y. Now look what happens when I do that. So here's my original graph, and here's a half of y. So let's do a half of y. And when I do that, my x's all remain the same. Okay, so I have -3, -2, -1, 0, 1, 2, 3, and I'm going to take half of all the y's. So I have 4.5, 2.5, 0.5, 2, 4.5. And it looks like someone sat on the graph. Ouch, but it looks like it's been squished, okay? So basically, this looks like the graph has been sat on. So it's been squished, which is my famous term. It's been squished, or the more mathematical term has been compressed vertically. Okay, so let's look at if we can see what a rule would be by vertical stretching and compression. So I'm going to try to make this understandable. If f is a function and k is a constant, then the graph y equals k f of x is the graph of this original function, vertically stretched if k is greater than 1, and vertically compressed if it's between 0 and 1. Okay, so first of all, the word you got to remember is you're now multiplying. That's a big deal. Okay, so if I have this function y equals k of something, so I'm multiplying this function by a constant, If k, right here, is greater than 1, then it's stretched vertically. How does that affect our table? Well, that means my x values are the same. They remain the same. And my y values are multiplied by k. If k, all right, is between 0 and 1, which means it's a fraction or a decimal, okay, it's compressed, or sat on, if you will, compressed vertically, and it's going to have the same, your x value is going to remain the same, and you're still going to remultiply it by whatever this is, but it's going to show that it's been compressed. So this works for both of them. You're still going to multiply, all right? So that's how it works for our table. Now, I've used some trig functions. I know we haven't done trig functions yet, but I know you did them last year. And I want to show you what you did last year. So I have this function y equals sine x. So let's just look at the graph from here to here, okay, if you will. And you'll see there's sine of graph, and I've actually put in the table for that. Now, last year you learned that right here inside was called your frequency. So last year you looked at it and say, oh, my frequency is a half, so I only see half of my graph. And here it was a 2, so you're going to see C2 of your graph. Now, let's take it into what we're learning this year. Well, if I take this and it's a half, now this is an inside change. Inside changes are opposite. Okay, inside changes are opposite. So what you're going to see now is, here's my x values, and I know they're not pretty, but it doesn't matter. If I want to only see half of it, because it's an inside change, it's opposite, I'm actually multiplying my x's by 2. So inside changes always have to do with your x values, and they're always opposite. So if I'm taking half of it, I'm actually multiplying my x's by 2. What that does is it stretches your graph. So see how it's been stretched? So if I'm looking at just this piece of it, like, because that's what we looked at here, I only see half of it now, don't I? So when I see half, it's because it's been stretched. It's been stretched horizontally. So this has been stretched horizontally. Now here's the problem with this. It's not really a problem, but you'd have to wrap your mind around it, is that it's opposite what you think. If I only see half, now think about that, I have stretched it so I only see half. That's why I have to multiply all my x's by 2 is to space them out farther. Okay? This one here, I see 2 of them, so from my original graph, I'm only going to take half of my x's, and if you'll see, these are half as much. It's been horizontally compressed. It's been squished this way like a spring. So this is going to be compressed horizontally. Now let's think about that too. Again, the opposite part I know bugs people, but if I compress my x's, then it'll happen more often. Therefore I see more, therefore it's compressed. Okay? So let's look at the rule for that. What are the rules for horizontal stretching and compression? Well, if f is a function and k is a constant, the graph of y equals f of k of x. Now notice the k is on inside, is the graph of my original function, and this is what happens. So here I've got y equals f of k of x. So remember, opposite because it's an inside change. Okay? Now I'm going to give you an example with each of these. So right here, if I have, ready, k is less than 1. So it's a fraction. Okay? It's horizontally stretched. Stretched by a factor of 1 over k. All right, let me tell you what that means. So for example, okay, if I had the graph of y equals a half x squared, so I just picked this graph. If I wanted to figure out what's really happening to my original graph of y equals x squared, that's my original, I say, oh, I stretched it by a factor of 2. So see how it's flipped? So on my arrow, I would say 2 times my x's, because I've stretched it by that flipped. That's what that 1 over k means. Okay? So it's stretched. I can make a t here. Stretched by a factor of 2. All right? Now, let's go the other way. If k is greater than 1, it's horizontally compressed by a factor of 1 over k. So the example to help you get this in your head is y equals 3x squared. So do you see how the 3 is greater than 1? So basically, if I'm going to talk about what do I have to put on this, it has to do with my x's because it's an inside change. I'm actually compressing it by 1/3, so I see 3 of them. So it's compressed by 1/3. Okay? All right, let's go and do an example where we have a ton of them in here. And here is a graph. I have this graph of y equals f of x. Okay, that's my original graph. All right, now I didn't even give you what it looks like. Don't worry about it. But now I've done this to it. So like you can actually do this with everything. Okay? So I look at it, and so you always have to work inside out. And so this is what we're going to do to the graph. We're going to start and do this first. Okay? So first of all, I'm working inside out. What I mean by that, work by the parentheses. And I see that I've changed my x's, or my inside, plus 3. So really what I've done is subtracted 3 from my x's because it's opposite, which means, what did I do? I shifted it to the left by 3. So it's a horizontal shift to the left 3. All right. Now here's step 2. So I've already done that. Now you go, and we also have to do this in steps. So I'm just going to use this a half. Now, isn't f of x y? So here, this whole thing here is y, so I'm going to do half of y's. So if I do half of all my y's, okay, that compresses it this way, compresses vertically, because I kind of sit on it, and it's only half my y's. Right? Now we have a negative to take care of. So now I have to negate my y's. See, all these have to do with y's. Only inside changes have to do with x. So when I negate my y's, I reflect this graph, the x-axis. And it's, so basically you can say this graph has flipped. All right? Now, step 4 is I have to take, so I've finished this, I've gotten that done, I've done that. Now the last thing is I'm going to take all my y's and subtract 1. When I do that, I shift it vertically down 1, so it's shift vertically down. So what we did with this original graph, was we shifted it to the left, squished it, compressed it vertically, flipped it, reflected over the x-axis, and dropped it down. So you can actually do that with each step with tables and come up and graph the very end of it, and you'd have it moved. All right? So let's try one. And I know there's another one here, but we're not going to do it. So we're just going to do this one together. And I'm going to pick a weird graph so that you can kind of see this happening. So here's the points I'm picking. Negative 5, 0. Negative 2, 3. Negative 1, 1. 0, 0. 1, negative 2. And 5, negative 2. So this is my graph. I'm going to do it in a different color so you can kind of see it, okay? So let's make this in red. So here's what my graph, whoops, I want to erase. Come on. Oh, erase this. Let's try this again. There, it's kind of got stuck. Oh, it's not letting me write now. It's being very picky on me. Let's see if I can get this to work. Alright, so I have negative 5, 0. Sorry about the delay. Negative 2, 3. negative 1, 1, 0, 0, 1, negative 2, and 5, negative 2. Okay, we'll try this again. So here is my graph. Kind of looks like this. All right? Weird looking little graph, but it's good. All right? So here's my graph. Now we are going to do all this to it. So I'm going to go back. I'm afraid to change colors kind of because I acted up last time. And we're going to do all the tables and do this to it. So let's figure out what this is having us do. So the first thing this is, we work inside out, is so the first thing we have to do is it's doing an inside changes. So I'm moving all my x's 3 to the right. So I'm doing a horizontal shift. And it's opposite. So it's going to move 3 to the right. The next thing here is I'm multiplying it by 2, which means it's negative 2 times my y's. So I'm basically stretching it vertically 2 times. So I'm stretching it 2 times, okay? And then I have that negative there, so I'm going to reflect it over the x-axis. I'm going to flip it. And then I'm going to drop it down 1. Okay, so it's going to go down 1 vertically. So let's go through that again. This is what we're going to do to this little weird graph. First I'm going to shift it to the right, stretch it, flip it, and drop it down. Okay, so let's go with the table. Sorry about that. Let's do the table. So I'm going to do them here on the bottom a little bit. So here is the original graph. So here is x, y of my original graph. I need the room, so that's why I'm kind of going on the graph. So I have negative 5, 0, negative 2, 3, negative 1, 1, 0, 0, 1, negative 2, and then 5, negative 2. Sorry, I'm running out of room here. So next one I'll make it a little higher. First thing I want to do is add 3 to my x's. So I'm going to make my x, y a little higher so I have room for everything. Okay? Now, if I add 3 to my x's, I do not touch the y. So the y is 0, 3, 1, 0, negative 2, negative 2. All right? Now I'm going to add 3 to all my x's. So this is what I get. Negative 2, 1, 2, 3, 4, 8. Okay? Don't graph it. Now I've just shifted it to the right. The next thing we want to do, we want to stretch it by 2. But you know what? I'm going to put these two together. I'm going to stretch it by 2, and I want to reflect it over the x-axis. Now, so basically I'm looking at this negative 2. Now, it's negative 2 times my y. So I'm going to take my, as long as you know you're doing two things, I'm going to do negative 2 times my y. When I do that, not only am I stretching it, but I'm flipping it all in one spot, in one time. Okay? You can split that up. So I'm basically leaving my x's alone, negative 2, 1, 2, 3, 4, 8, and taking all my y's and multiplying by negative 2. So that's 0, negative 6, negative 2, 0, 4, 4. Okay, so I've shifted it to the right, stretched, and flipped it. And the last thing I have to do is take my y's and subtract 1 because I'm dropping it down. Right? So I'm going to kind of get off this graph because I got to use this graph, so I'm going to make the arrow down a little bit lower, guys. So I'm going to say y minus 1, and then my graph is, all I'm going to do is take my y's and subtract 1. And you know what I might do is not put this on the graph here, is do this over on the side. So you are going to do y minus 1, and then so my ending table of values for me to graph is going to be this. So my x's will stay the same. My y's will drop down 1. Subtract 1 from all my y's. Okay, so now when I graph this, let's see what happens. So I have negative 2, negative 1. Then I have, okay, 1, negative 7. All right. Then I have, what do I have next? 2, negative 3. 3, negative 1, 4, 3, and then I have 8, 3. Okay, so now my graph kind of looks like this. Sorry, I'm sure you can, yours looks prettier. Whoops. What was that, 3? 8, 3. Okay, so let's see if it looks like it. Does it look like it shifted over? Yes. Does it look like it's been stretched? Yeah, it looks longer. Does it look like it's been flipped? Uh-huh. And does it look like it's been dropped down? Definitely. Okay, because it's a lot lower than it was. So that's how you do multiple transformation.